Greetings, fellow scholars. I am Amy Benzi, representing North Central University. The purpose of this presentation is to analyze the randomized experimental design. In analyzing the randomized experimental design, we will distinguish between random selection and random assignment. Next, examine the advantages and disadvantages of simple random, systematic, stratified, and cluster sampling through a hypothetical study. We will also discuss combinations of different sampling methods and the advantages and disadvantages of them. Studies done with correct probability sampling methods can produce outcomes that can be used to project possible outcomes from a sample onto a larger population. Some probability sampling methods are simple random sampling, where each element is considered and each element has an equal chance of being selected. Systematic sampling, where every nth element was chosen to start at a random number and to pick every nth element in succession. Stratified sampling, where the population is divided into subpopulations or stratum, and subjects are selected randomly. Cluster sampling, where our population is divided into clusters, and random samples of clusters are selected in the form of simple random design. First, review random selection versus random assignment. Random selection means that participants are randomly selected to participate in a study. Random selection can include simple random selection, systematic random selection, stratified random selection, or clustered random selection. Random assignment means that subjects are randomly assigned to study groups, usually referred to as the control group or experimental group. Once participants are randomly selected to participate in the study, they can then be randomly assigned to which group of the study they will belong. Participants can be randomly selected by simple random, systematic, stratified, or cluster selection. Participants can be randomly assigned by simple random or systematic assignment. To analyze the randomized experimental design in this presentation, refer to a theoretical study on how the relativity of math content to the personal lives and careers of Arkansas two-year college students affects students' learning outcomes and attitudes about mathematics. The population for this theoretical study is the group of students enrolled in core college math courses in Arkansas two-year colleges during the fall semester of 2020. Using the hypothetical study, examine each of the four probability sampling methods: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. The probability sampling method, simple random selection, allows each member of the population an equal opportunity to be chosen to participate in the study, and simple random assignment allows each participant an equal opportunity to be assigned to either the control group or the experimental group. In the case of this theoretical study, the two groups are the math course college algebra, requiring the manipulation of abstract algebraic algorithm with content relative to less than 6% of college graduates, and the math course quantitative reasoning, requiring calculations of mathematics relevant to the personal lives and careers of all productive citizens. Simple random selection and assignment provide both internal and external validity, which provides results that can be used to predict outcomes of similar experiments onto larger populations, and findings can also be used to generalize the causes of outcomes and effects of applications. In this theoretical study, a simple random selection is produced by listing every student enrolled in Arkansas two-year college core mathematics courses. After creating a list of every student in Arkansas's two-year colleges enrolled in a core college mathematics course, each student is then assigned a unique number between 0 and n, where n represents the sum of the number of students enrolled in core math courses throughout the state. Next, use the random number generator in Excel to randomly choose 200 students from the population. For this theoretical study, we will let n represent 6,000. After randomly selecting 200 participants from the student population, then randomly assign those students to either the core college math course, Quantitative Literacy, or the core college math course, College Algebra. Using the Excel random generator, randomly assign each student either a 0 or a 1. Let the number 0 represent the core college math course, Quantitative Literacy, and let the number 1 represent College Algebra. This form of random assignment allows each student an equal chance of being assigned to either course. Here's a review of some advantages and disadvantages of using simple random selection and simple random assignment. Simple random selection provides the external validity of the experimental results. The level of external validity provided by simple random selection provides results with outcomes that can be used to predict similar outcomes of larger populations. Another advantage of simple random selection is that each student has an equal opportunity to participate in the study, reducing bias and reducing the possibility of some part of the population being either under or overly represented. When each member of the population is equally represented, then bias is highly reduced. Because simple random selection offers external validity, results can confidently reveal strategies to improve learning outcomes of larger populations. The study results may also reveal strategies that can improve math attitudes of larger populations. There are some disadvantages to using random selection. Because there are 27 different schools in Arkansas and each student has an equal chance to participate in the study, there's a vast number of schools with which to coordinate. The sample of this study would be very spread out. It would be unfeasible to add any observation element to the research design because of the distance and different locations of the subjects of the study. With the possibility of over 24 schools, it might be necessary to have to use multiple different learning management systems to collect and evaluate data. The time and budget required to communicate with administration, faculty, and technical and human resource staff from each school is not realistic for a small-scale research project. Using a random selection method other than simple random selection may allow for a larger sample size. Simple random assignment advantages start with strengthened internal validity of the relationships revealed between the variables being measured. With outside bias and outside variables minimized by pure random assignment, relationships revealed between variables can be used to identify causes of improved learning outcomes and math attitudes, and also determine the effects of relevant math content. Random assignment in this study means that every student has an equal chance of being assigned to the math course with relevant math content, and the chance being assigned to the college mathematics course having life and career relevant content. Some disadvantages of a random assignment are, for one, degree requirements determine which math course students go into, and students are not likely to agree to take an additional math course not required in their degree plan. Also, students may not get financial aid for a course that is not in their degree plan. Another disadvantage is that some students will not learn relevant material if they are put into the college algebra course, where 96% of college graduates will not apply the content of the course to their personal lives or careers. The validity of random selection combined with random assignment produces a respected level of validity, creating a mindful caution about reporting results and also raises ethical concerns of privacy and guaranteed random assignment. We have examined random selection and random assignment. Now, examine systematic sampling. Systematic sampling starts with taking every nth element chosen from a random starting point. Now examine systematic selection and systematic assignment. Use Excel to create a list of every student in Arkansas who is enrolled in a core college mathematics course and assign each student a unique number between 0 and n, letting n represent the number of students assigned. Next, use the random number generator in Excel to randomly choose a number between 0 and 100, and we get the number 30. So since we started this list at 0, counting off 30 students brings us to 29, and then every 30th student after that would be chosen to participate in the study. After systematically selecting the sample, participants can be systematically assigned to groups. To systematically assign participants to a group, choose every student who was selected from the systematic selection and systematically assign the first student a 0 and the next a 1, and the third a 0 and the fourth a 1, and continue in this manner until each participant has been assigned a 0 or a 1. Students assigned 0 would take the core mathematics course with relevant mathematics content, and students assigned a 1 would take the core college mathematics course with non-relevant course content. Examining some of the advantages and disadvantages of systematic selection and systematic assignment. The advantages and disadvantages of systematic sampling are identical to those for simple random sampling. External validity means results can predict outcomes onto larger populations. Equal opportunity for each student to take either course exists. Bias and variables are reduced, and strategies may be revealed to improve learning outcomes of larger populations and to improve math attitudes of larger populations. Some disadvantages of systematic selection are that a large number of schools to coordinate with. Samples are very spread out, reducing access to participants. The requirement of using multiple different learning management systems to evaluate and collect data is time-consuming, along with the necessity to communicate with many different schools. The study is restricted by the number of students that can be evaluated because a large sample size with this method of sampling would be far too expensive and time-consuming. Some of the advantages and disadvantages of systematic assignment are, again, the same as simple random sampling. Internal validity of the relationships revealed between variables is highly respected, and the relationships that are identified can be used to generalize the causes and effects between variables. The causes of improved learning and math attitudes and information about the effects of relevant math content can be inferred. Each student assigned to participate in this study has equal opportunity to be assigned to either course. The third probability sampling method examined in this presentation is the stratified probability sampling method. In the stratified sampling method, the population is divided into subpopulations or stratum. The subjects are selected randomly. Stratified sampling produces valid internal and external results to project outcomes of larger populations and to show the causes and effects of applications. Suppose that for this study, a stratified sample is taken. To perform a stratified sample, list the 27 Arkansas two-year colleges into Excel and assign each school a number between 0 and 26. Next, use the random number generator in Excel to choose 5 numbers between 0 and 26 to choose schools to participate in the study. Excel chose schools assigned to numbers 22, 26, 13, 14, and 10 to participate in this study. Use Excel to calculate the proportional percentage of students needed from each school to produce a sum of 200 students. Use the natural strata created by the schools for students already enrolled in either the college algebra or quantitative literacy course. Create lists for each school and list each and every student that is either enrolled in the quantitative literacy course and every student that is enrolled in the college algebra course. Assign each student a number between 0 and n, letting n be the number of students needed for the list. Calculate half of each percentage to determine how many students need to be selected from each class. Round each number up to an even digit. Use the random number generator in Excel to randomly choose the relative number of students from each course who will participate in the study. Some advantages and disadvantages of stratified sampling are again that the external validity of the experimental result is projectable onto larger populations. Strategies may be revealed to improve learning outcomes of larger populations and to improve math attitudes of larger populations. Fewer schools must be coordinated with random or systematic sampling. Classes are naturally divided into strata of quantitative literacy and college algebra, which saves time and resources. Some disadvantages of stratified sampling are that 5 chosen schools may not represent the entire population. Students working towards science, technology, engineering, and mathematical degrees have a higher success rate in math courses, so removing the random assignment of the courses introduces academic bias. The time required to communicate with 5 different schools can be cumbersome, and the statistical measurements needed to analyze stratified sampling are more complicated and entailed than those of random or systematic sampling. Also, we may be able to experiment on larger samples if fewer schools are engaged in the coordinate of the study. Last but not least, the probability sampling method called cluster sampling is analyzed. In a cluster sampling, the population is divided into clusters, and then random samples of clusters are selected by simple random design. Cluster sampling also produces valid internal and external results to predict outcomes of larger populations and to show causes of outcomes and effects of applications. In cluster sampling for this study, list the 27 Arkansas two-year colleges into Excel and group the schools into clusters according to enrollment numbers. Let Group 1 include schools with an enrollment of less than 1,000, Group 2 have enrollment numbers between 1 and 2,000, Group 3 have enrollment between 2 and 3,000, and Group 4 will have enrollment higher than 3,000. Using the random number generator in Excel, generate 2 random numbers between 1 and 4, and Excel chooses groups 3 and 4, eliminating groups 1 and 2 from the study. From the first cluster, Excel is used to generate a random digit between 1 and 9, and Excel chose 7. For the second cluster chosen, Excel generated a random number between 1 and 6, and the number chosen is 4. School number 7 from Group 3 and School 4 from Group 4 are chosen to participate in the study. In cluster sampling, every student enrolled in a core mathematics course from Schools 7 and 4 are chosen to participate in the study. Some of the advantages and disadvantages of cluster sampling are that external validity of the experimental design results are projectable onto larger populations. Strategies may be revealed that improve learning outcomes and math attitudes. Outcomes can be used to predict outcomes similar experiments of larger populations. Having only 2 schools to coordinate allows for an increased sample size. Schools and classes are naturally divided into clusters, so fewer resources are needed to collect data. Some of the disadvantages of cluster sampling in this study start with the fact that level 1 and 2 schools are underrepresented and level 3 and 4 schools are overrepresented. Students working toward STEM degrees have a higher success rate in mathematics courses, which introduces academic bias. Increased sample size increases data collection procedures and tasks and makes statistical measurements more complicated than it did with random and systematic sampling. Cluster samples are also more prone to bias and sampling error. After examining 4 probability sampling methods, simple, random, systematic, stratified, and clustered sampling, we can look at some of the possible combinations that can be used to conduct experimental research. Simple random selection with a simple random assignment produces the least bias by controlling outside variables. Simple random selection can be combined with a simple random assignment or with a systematic assignment to create minimum sampling bias. Systematic sampling can be combined with either simple random or systematic assignment. Stratified sampling can also be combined with simple or systematic assignment, as well as can cluster sampling. The randomized experimental design was analyzed in this presentation through the lens of a theoretical study of how the relativity of math content to the personal lives and careers of Arkansas's 2-year college students affects students' learning outcomes and attitudes about mathematics. 4 methods of probability sampling were analyzed. We distinguished between random selection and random assignment, examining the advantages and disadvantages of each of the 4 sampling methods discussed. Thank you for listening to my presentation.